Yes, student. Next topic is physical properties of haloalkanes. Student, what are the physical properties? Physical properties means the physical nature or the behavior. Like in physical property, we will discuss state, okay, order, color. Okay. Next one, we will discuss solubility. Solubility. Now, solubility in two parts. Part number A, what? Solubility in water. And part number B, solubility in organic solvent. Organic solvent. Okay. Some more physical properties are there, which we will discuss later. So first one, state and order. Lower members like CH3, F, CH3, Cl, CH3, Br and CH3I. They are what? Lower member are gases at room temperature. Gases at room temperature. Okay. But higher members, okay, are liquid, and more higher member will become what? Solid. Okay. Now, what is the reason behind it? So, actually what? The physical property, okay, depends on intermolecular attraction force. Okay. That is what? Physical state depends on which force? Intermolecular attraction force. Now, how many type of intermolecular attraction forces are there? Okay, so the intermolecular attraction forces are dispersed force, which is known as London force, induced dipole attraction force, third one is dipole attraction force, and fourth one is hydrogen bonding. Along with one more force is there, which is called van der Waals force. And the van der Waals force is universal. It depends on the molecular mass and the molecular size. Isn't it? Intermolecular attraction force means the tendency of attraction force to which the two molecules attracted with each other. As higher the magnitude of attraction force, which will depend on type of attraction force, more will the state will be changed. If the intermolecular attraction force is weakest in nature, like the dispersion force, okay, in that way the tendency to bind up of different molecule will be lesser, and therefore will become what? Gas. Student, depends on intermolecular attraction force. Haloalkanes, okay, are dipolar in nature. Dipolar in nature. How they are dipolar in nature? Say, this is CH3 and what? X. You can clearly see there is remarkable differences between the electronegativity of halogen and the electronegativity of carbon. Therefore, the halogen atom acquires partial negative charge and the carbon atom acquires partial positive charge. Means what? It is dipolar in nature. Now, what about intermolecular attraction force? So, intermolecular attraction force means this is one of the molecule and this is X, fraction negative, and this is what? Fraction positive. So, this one is one molecule. If you see next molecule, again this is CH3 and this is what? X, fraction negative and fraction positive. Now, when two molecules with opposite charge come close to each other, it forms what? Dipole attraction. attraction. Dipole, dipole, what? Attraction. Okay. In the case of lower member, in the case of lower member, magnitude of what? Dipole attraction. Dipole attraction is weaker. Why weaker? Due to lower, okay, molecular mass, lower molecular mass and smaller size. Isn't it? So if we consider about CH3F, okay, CH3Cl, CH3Br, CH3I, they are what? Lower member, and when they are lower member, okay, the dipole attraction force is present. Although this attraction force is quite strong, however, the van der Waals attraction force is very weak, and due to weaker van der Waals attraction force, okay, they exist in gaseous form. Are you getting? Is weaker due to lower molecular mass and smaller size. That is what? Van der Waals attraction force is weaker. Van der Waals attraction force is weaker. Okay. Now the higher member, I told you, higher members are liquid and solid. Okay. In case of higher members, what? Van der Waals attraction force will increase. Van der Waals attraction force will increase. Now, why van der Waals attraction force will increase? It is due to increase in molecular mass and molecular size. So we can write here, due to increase in molecular mass and size. Therefore, they becomes what? Liquid, and the more higher member will become what? Solid. Now the next one about the orders, okay, and color. Alkyl halides, okay, especially if you talk about CH3F and CH3Cl, okay, in pure form color rays, and sweet smelling, that is their order is what? Sweet. Okay, but the higher members, okay, becomes colored. Higher member becomes colored due to expose in sunlight or atmosphere. Yes, student, next physical property is solubility in water. Getting? Haloalkanes and arenes also, okay, should be soluble in water. Okay, remember I am saying what? Should be remembered in water. Why it should be remembered in water? Because H2O and Rx, okay, or are polar in nature, or are polar in nature. So they should follow like, dissolve, like, dissolve, like concept. What is the meaning of like, dissolve, like concept? The meaning of like, dissolve, like concept is if the solvent is polar and the solute is also polar, then they should dissolve in each other. That is, solute should be dissolved properly. If the solute and the solvent both are non-polar, then they will also dissolve. This is called like, dissolve, like concept. But exceptionally, what haloalkanes, that is Rx, are insoluble in water, or insoluble, okay, in water. That means what? Now it becomes what? Question. According to chemistry concept, there should be dissolved, okay, but it does not dissolve, so there should be a question. Why? So the reason is, it is because although Rx is polar, and these molecules have dipole-dipole attraction, okay, but in water there are what? Hydrogen bonding. There are what? Hydrogen bonding, okay, which is very strong attraction, which is very strong attraction, force, okay. When Rx and H2O, okay, are added, then a new attraction force should develop, but the energy release is very low. Which is unable, or you can say what? Insufficient. Unable or insufficient, low energy. Insufficient, low energy is unable to break what? Hydrogen bond. Unable to break hydrogen bond exist, okay, between water molecules, between water molecules, and in the hydrogen bond of water is unable to break, therefore the haloalkanes remains insoluble in water. But student, what about organic solvent? The organic solvent like benzene, like ether, like chloroform, when haloalkanes are added with this solvent, after adding, the energy is getting released, and this energy is sufficient to break the older intermolecular attraction force exist between haloalkanes and the chloroform, and thus in organic solvent haloalkanes are soluble in water. So student, one of the question from this part is often asked in exam. Student, next content of physical property is boiling point of haloalkanes and haloarenes. Haloalkanes and haloarenes. Again, student, the boiling point will depend on intermolecular attraction force. In fact, what? All the physical properties directly depends on the intermolecular attraction force. Very first, we have to understand what is the meaning of boiling. The meaning of boiling is breaking the attraction force exists between the molecules so that molecules can convert into vapor. Like here, there is attraction force, and suppose it is in liquid nature. So if we have to boil it, means we have to break attraction force, and now the each molecule will become isolate and therefore will convert into vapor. This is known as boiling point, isn't it? Means what? Before discussing boiling point, again we have to discuss intermolecular attraction forces, isn't it? You further know one thing, that the haloalkanes and the haloarenes are derived from their respective alkanes and aromatic compound, that is what? Benzene. That means we can also compare the boiling point of their parent compound, that is alkanes, and the boiling point of haloalkanes, whether they are same or different, isn't it? So very first, let's check Rx and ARX are dipolar in nature, hence dipole okay, strong attraction force exists between molecules. So their boiling point are higher than corresponding what? Alkanes. Corresponding alkanes to which they derive, because alkanes are non-polar molecule. Alkanes are non-polar molecules. Hence weakest attraction force. Force. And which one is weakest attraction force? This is what? Dispersion force exists. force exists. So what? In alkanes, the weakest attraction force due to non-polar in nature, which is what? Dispersion forces exist. Okay, so being the attraction force is weak, to break this attraction force require lesser energy, therefore their boiling point is lesser. But in the case of Rx and ARX, okay, their attraction force, that is attraction force between them, is what? A strong attraction force of the type dipole, and therefore their boiling point are higher. Okay, I have some comparison of boiling point. Like if we discuss the boiling point of CH4, if we discuss the boiling point of CH3Cl between the CH3Br and CH3I, you can see here the boiling point of methane is only 111. Okay, in what? Kelvin, not degree Celsius. In what? Kelvin. But if we discuss CH3Cl, it becomes 249. Okay, if we took CH3Cl Br, it is what? 277, and for CH3I, this is what? 315 Kelvin. Now why? Because methane, it is alkane, and alkanes are non-polar, but all these molecules are what? Dipolar, and therefore strong attraction forces exist. Again, you can check here, the boiling point increases as the halogen atom changes, like in increasing order. Okay, now this is Cl, this is Br, and this is I. So what happens actually here? All of them are alkane halide. But one more thing, okay, is what? The molecular mass will increase, because the molecular mass of Br is more than Cl and I is more than Br, and we know that as the molar mass increases, the van der Waals attraction force also increases, and due to increase in the molecular mass, the van der Waals attraction force, their boiling point also increases. Okay, so we can write, so for same alkyl group, for the same alkyl group, as the size of halogen atom increases, halogen atom increases, halogen atom increases, molar mass increases, molar mass increases, and van der Waals attraction force increases, attraction force increases. So boiling point okay, also increases. So student, to discuss boiling point, not only we have to focus on type of intermolecular attraction force, but also we have to focus van der Waals attraction force, which is universal attraction force and act, okay, and depends on molecular mass and molecular size. So if the molecular mass will increase, the magnitude of van der Waals attraction force will increase, although all of them are having dipole attraction. Okay, but its van der Waals attraction force is more than CH3Cl, therefore its boiling point is higher than CH3Cl. Okay. Now, student, next one, boiling point of haloalkanes and haloarenes in case of same halogen but different size of alkyl radical. That means what? Here we have not to change what halogen. We are going to change only what alkyl radical. Like if we compare the boiling point of chloro compound, and this is what CH3Cl. Sorry, this is what CH3Cl. And now I am increasing the size of alkyl radical. Like now it is what C2H5Cl. Now it is what C3H7Cl, and now it is what CH3, CH2, 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 and what Cl. All are straight chain. Okay, normal profile. You can write it what normal profile, or simply you can write this in this manner like that. Okay, so CH3Cl or C2H5Cl and C3H7Cl or C4H9Cl. So if we see their boiling point, the boiling point of CH3Cl is 249 Kelvin. The boiling point of C2H5Cl is 285 Kelvin. The boiling point of CH3Cl is 320 Kelvin, and it is approx 342 Kelvin. So here again you can check the boiling point is gradually what increases. Now can you do why the boiling point is gradually increases? So again the same reason as we have observed in previous what increasing van der Waals attraction force. How it is? In first molecule the molecular mass is very low. In second molecule, the molecular mass increases due to increase in size. In the third molecule, the molecular mass again increases due to 3 number of carbon atom. And the last one, there is what 4 number of carbon atom. Therefore, their boiling point is higher. So the van der Waals attraction force is also higher, and therefore boiling point gradually increases. Okay, we can discuss one more thing. For isomeric haloalkane. Isomeric haloalkanes. Now, student, what are isomeric haloalkanes? The isomeric haloalkanes, that is what the molecular formula is the same. Okay, molecular formula is same, but structural formula are different. That is, some molecule can belongs to straight chain, some belongs to branched, and some belong to highly branched. Okay, I can take example of C4H9Cl. Okay, C4H9Cl. But how many structures of C4H9Cl are possible? Or suppose we are writing C5H11Cl. Okay, for this you can see CH3. Look at this is what Cl. Okay, straight chain. We can write one more 1, 2, 3, 4, and now here one of the Cl and one of the Cl and CH3, that is branch. This become what branch, and we can see one more 1, 2, and 3, and this is CH3, this is what CH3, and again this is what Cl. So you can see here the chlorine attached to first carbon atom, but their isomers are having different structure. This is what symmetrical structure. This is what symmetrical structure. Now being the molecule is symmetrical, the next molecule can attach directly with this molecule. That means what? The contact area will be very high. That means what? The force of attraction will be very high. Now, being the force of attraction is very high, to break that force of attraction require high energy. But in second molecule, look at here, it becomes little branched. Okay, now being the molecule becomes more branched, it becomes what? Unsymmetrical. Okay, and due to unsymmetry, the next molecule will join from here. That is what? The contact area, that is surface area to which they contact, that is two molecules contact, will be lesser. Therefore, the force of attraction will be lesser. If less force of attraction, then require lesser energy. And look at here the third molecule. Here the molecule becomes almost what? Spherical in state. That is highly branched. Okay, so being the molecule is highly branched, the next molecule will join from this side. That means the contact area is very less, and being the contact area is very less, the energy required to break this attraction force is also very less. Therefore, it has least boiling point. Therefore, what we are saying, this molecule has least boiling point, while this molecule has highest boiling point. So we can say here the boiling point is highest here and the boiling point is lowest here. Okay. So we can see here for isomeric haloalkanes boiling point decreases. Boiling point decreases as the branching takes place. Because branched molecules have very low surface area, or you can say what? Surface contact area. So force of attraction is lesser. Okay. Therefore, boiling point gradually decreases. Now, student, in this whole content, I explained all the properties, say physical state, color, order, solubility, boiling point, belonging to haloalkanes only, but haloarenes are also given there. So what you have to do? You have to discuss all these property for what? Haloarenes. So this will be your homework. Okay, you have to discuss the physical property for haloarenes. Okay, student, you must have to prepare proper notes. Okay, you have to solve the in-text question given in the NCERT book. Okay, so that you can secure good mark. Timely, I am giving you homework and I will check this also.